Okay, so we're going to look at 2 by 2 matrices. So if we have a matrix M defined by A, B, C, D, A, B and C, A, B, C and D are real numbers, well that's all we're going to consider for now. Then the determinant of A, denoted, of M, sorry, denoted det M, can also be written as such, or you can substitute M in for its component and write it like that, just so you're familiar with the notations, is equal to AD minus BC. In the 2 by 2 cases, it gets a little bit more complicated in higher dimensions. The formula for 2 by 2, 3 by 3, 4 by 4 and so on is the same. It just so happens that in 2 by 2 this can be simplified to this simple little formula rather than having to go through the whole algorithm you do with the other ones. I should mention as well, you can only find the determinant of square matrices, so 2 by 2, 3 by 3, 4 by 4 and so on. And in the 2 by 2 case, the determinant of M gives the scale factor of the transformation represented by M. So, in other words, when you apply M, how is the size of your shape going to be affected? Okay, what's the scale factor going to be? So let's have a look. Let's calculate some determinants, and the first two we're going to know what the transformation is, so we can see the scale factor come into effect. So if we have a matrix S equal to 3, 0, 0, 2, well, we know this is a stretch in the x direction by scale factor 3 and a stretch in the y direction by scale factor 2. So that's not the symbol I meant to put. Our determinant of S is equal to 3 times 2 minus 0, but we won't put that. It's equal to 6. Well, this makes sense as a scale factor because we're stretching in the x direction by 3 and in the y by 2, so overall the shape gets 6 times bigger. Okay, we have another matrix A, 1, 0, 0, 5. Well, this determinant is just equal to 1 times 5, which is 5, and we've got no stretch in the x, stretch of 5 in the y direction, so it makes sense again that the scale factor would be 5. Right, so now you can see that idea works. We might have a matrix now where we're not too familiar with what this transformation actually is just by looking at it, but we can still get the scale factor. So the determinant is equal to 6 times 3 minus 2 times 1, that's equal to 18 minus 2, that's equal to 16. Okay, so hopefully from seeing a few examples you can understand how to calculate 2 by 2 determinants. I'd encourage you to just try a few examples. Make sure you get your head around this. This comes in handy for finding the inverse of a 2 by 2 matrix, which we will look at in another video, but perhaps in the next video we'll look at the inverse of a 2 by 2 matrix and the determinant of a 3 by 3 matrix. Okay, so look forward to that. I do already have videos on these, but as part of this series I'm going to go through them again. If you do want to check those out, I'll leave them linked below.